The objective of this project is to build a robot that competes in the ME2110 competition, Fantastic Beasts: The Crimes of Grindelwald. The competition field consists of 4 home zones and 1 central rotating platform that is Azkaban. Within each home zone is a rubber Dementor. This Dementor is worth negative 13 points and thus must be removed from the home zone.
Expecto Patronum!
On Azkaban there are 4 squash ball nifflers and 8 shiny gems that can be collected. The gems are worth positive 4 points each and the nifflers are worth negative 10 points each, so the two must be separated to gain points. Finally, after waiting for an indeterminate amount of time for the gates of Azkaban to be lowered,
I did my waiting! 12 years of it!
a tennis ball Grindelwald can be imprisoned inside Azkaban for 15 points. Only one team can score these points. By applying a bit of game theory to the competition, we can formulate a strategy for winning. Given Azkaban's slow rotational velocity in relation to the average team's quick extension velocity, each team will only be able to reliably secure one set of 2 shiny objects and a niffler, of which the niffler is passed to another team's zone. With each team scoring the same number of points from shiny objects, 16 with egress, the next point differentiator is Grindelwald. He is crucial because only one team can imprison him and score the 15 points. Due to this, imprisoning Grindelwald is our top priority. The next priority is removing the Dementor, as it is guaranteed to be in our zone and will detract 13 points if not removed. Blocking nifflers is the next priority because, while potentially worse than Dementors, their ending positions are mostly random. That is not to say that collecting shiny objects is not a priority, only that the number of people collecting objects will dilute the potential score to the point where objects are collected not to gain points, but rather to deny those points to another team. But hey, that's just a theory. This first concept builds off the device we have constructed for the Niffler and Grindelwald subsystem challenges. It utilizes a main drawer slide extender powered by a winch and pulley system. On the end of the final stage is a small catapult for imprisoning Grindelwald within Azkaban. It is triggered by a solenoid. In the middle of the final stage is the object Niffler separator, which uses a long slotted ramp that separates the two based on diameter. At the end of the final stage is a grappling hook that falls when it passes over the Dementor, hooking the Dementor. This is retracted by the same motor that causes egress. Finally, a pneumatic sweeper arm clears our home zone of any nifflers.
The second concept design relies heavily on scissor arms for extension. The Grindelwald, Shiny Gem, and Dementor subsystems all reside at the end of the central scissor arm, which is extended using the pneumatic piston. The Shiny Gem subsystem collects the nifflers and gems with a curved piece of wood, and the nifflers roll down and off the ramp, while the gems fall through a slot into the home zone. The Grindelwald subsystem activates when the walls drop, and a piston pushes up this ramp, causing the wooden Grindelwald holder to slide down and release Grindelwald into Azkaban. A wooden beam behind the gem system drops down by mousetrap and acts as a wedge to pull the Dementor into the starting zone when the scissor arm egresses. Lastly, the 2 angled scissor arms will be deployed by motors and will be defensive boundary walls.
Alternative Design 3 utilizes a mousetrap-actuated folding arm to extend its mechanism to reach Azkaban and the Void. Once the arm is extended, a wall is used to corral nifflers and gems into a ramp-style sorting mechanism that sorts the objects by size. This style mechanism has no fragile components and relies only on gravity. On the same folding arm, a catapult-style mechanism is mounted to launch Grindelwald once the gates are lowered. The design also uses a drawer slide and rake mechanism to drag the Dementor back into the home zone. Lastly, the design features an extending arm to block the opponents on the right-hand side of the field.
When ranking our 3 concepts in an evaluation matrix consisting of the aforementioned main criteria and a few smaller points from the House of Quality, Concept 1, the yellow-bellied slider, stood out as a winner. This was used as a basis and improved upon for the final design. The first system is the Grindelwald imprisonment system. The Grindelwald imprisonment system consists of a short mousetrap catapult held back by a solenoid. An IR sensor detects when the gate is lowered. This IR sensor is calibrated at the start of every match with a potentiometer so that the perfect threshold can be set for every position on every field. It can be set close to the IR sensor or farther away, depending on how our robot sits on the field. This gives the device a snappy response time to the gate being lowered, and the mousetrap catapult, with its short moment arm, ensures that our robot imprisons Grindelwald as quickly as possible, like so. This system, minus the custom threshold, was used to great success during the Grindelwald subsystem test, where it quickly imprisoned Grindelwald all 3 times.
Following the Grindelwald system is the Shiny Object Collector and Niffler Dispersal System, aka Sockhand. A purely mechanical system, it sits at the end of the drawer slides at the correct height to be successful across all fields. It uses a curved scoop to direct objects off Azkaban and into a small box that sorts them by diameter.
The next system is the Dementor removal system. Instead of shoving the Dementor to another team's zone, our device pulls it to the starting zone with a set of grappling hooks. During testing, this was shown to have a higher success rate than sending it to another team's home zone. These grappling hooks are deployed via solenoid after extension to Azkaban, and snag and drag the Dementor during egress. While they do not look like much, they had great success in ensnaring the Dementor during testing, and were one of the few systems to successfully remove the Dementor during the Dementor subsystem test.
The final subsystem is the extension/egress system. Dual winches apply tension on different strings in the device. The winch with the large wheel tensions the string that extends our drawer slides, and the winch with the small wheel tensions the egress string. A long-arm momentary switch detects when the device has fully extended to Azkaban, and another switch detects when the device has fully egressed. By using these instead of hard-coded timers, our device is better equipped to deal with slight differences in the track and setup. While slow, this system is extremely consistent and allows for Grindelwald to be calibrated because we know exactly where it will stop.
With regards to the initial criteria, our robot did well. The biggest priority, a reliable Grindelwald system, was wholly accomplished with a system that could be fine-tuned to each field and would activate in a fraction of a second, giving it a 100% success rate per our tests. The next priority, a Dementor removal system, was also accomplished. While not as consistent as the Grindelwald system, it still succeeded in pulling the Dementor to the starting zone around 85% of the time. From there, our robot stumbles a bit. The extension system started off fast and competitive, but fatigue on the drawer slide slowly wore it down to a crawl, taking almost 10 seconds to extend compared to the 3 to 4 seconds it had during initial testing. This meant that our device did not reach Azkaban in a competitive time and missed out on all shiny objects and nifflers. Despite this, the Sockhand system proved effective when it had the chance, dumping shiny objects in our home zone and sending nifflers on their way. Lastly, our device was unable to block, perhaps its greatest flaw. Performance during the competition is a reflection of how successfully we met our criteria. In the first competition, we successfully deposited Grindelwald and removed the Dementor from our zone. We were too slow to get shiny objects, but we did not get any nifflers, giving us the first place score of 15 points. Our second round was much worse, with our extension system failing to completely overcome the friction from the fatigued slides. It never reached Azkaban, and a programming oversight meant that our system ceased function. Despite this, we were not dead last, finishing the match with negative 23 points. Due to our first round win, we still progressed to round 3, where our luck finally ran out. Despite successfully imprisoning Grindelwald, our lack of blocking mechanism allowed not 1, not 2, but 3 nifflers to enter our home zone. One of these nifflers also interfered with our Dementor hooks, causing the Dementor to stay in the zone as well. Without any gems to offset the negative points, we finished in last place with a score of negative 28 points, taking us out of the running once and for all.
While our performance during competition left something to be desired, we still left with a feeling of immense pride at what we were able to accomplish in just over a month. Observing our robot in relation to the other robots in the competition showed us what improvements we needed to make it truly succeed. If we had another chance, we would first implement a blocking system. We had a prototype scissor arm wall that could extend to the left zone boundary and take the Dementor with it, but the work needed to extend it was beyond what a motor could do, and pistons were too forceful with the delicate mechanism. More time would have allowed for improvements to this prototype. The next improvement would have been to the extension system. Greasing the slides again would go a long way to improving the speed, and we would have time to let it dry so we do not disqualify. This in turn would have let us increase the diameter of the extension winch, and therefore increase the extension speed. Addressing the biggest shortcomings of our robot with these solutions would result in a much more competitive and capable device. However, ME2110 taught us much more than just how to build a robot. It taught us how to approach projects of all scales and scopes, professional and personal. It taught us how deadlines, while stressful, are fantastic motivators for getting things done and avoiding procrastination. It taught us the usefulness of creating and executing a plan, however loosely structured it may be. Most of all, it taught us that we are Ramblin' Rex from Georgia Tech, and we are now officially hell of a engineers.